Hi friends, good morning. Today we are going to discuss NEET 2026 paper which is happened on June 21st, right? So as you know, the exam was very tough, especially concerned with the physics, right? So don't worry about this. When the examination is tough, definitely the cutoff will decrease, right? So let us directly go to the questions. See here, the first question is, a particle of mass m moves along the horizontal x-axis from x is equal to 0 to x is equal to L. Coefficient of kinetic friction as a function of x given, right? And alpha is a constant. One condition given here, the friction at length L, that is equal to 0. Now, the work done by this frictional force, that also they mentioned with an integer n. That n value we need to find, right? See, what is the work done? In general case, what is the work done? Work done is equal to work done by frictional force. Say frictional force is small f dx, right? Then frictional force generally you know that is mu n, right? So W is equal to mu n dx, right? Now what is the normal reaction? See, the situation is like this: one block at x is equal to 0 to x is equal to L, it is moving, right? So here mu k L is equal to 0 given. That means when it reach at a L position, this mu of L, that is equal to 0 given as a condition here, right? Now using substituting that, so here the mu value given, mu value is mu 0 minus alpha into at x is equal to L, x value is L, then you can solve alpha value, right? Then what is alpha? Alpha is equal to mu 0 by L, right? Now this block, what is the normal reaction? Normal reaction acting upward and weight is acting downward. So normal reaction is, that is mg. Now let us integrate this. Integral mu into what is n? N is equal to mg dx. Now mu value also I am substituting mu value they given as a function of x. Then mu 0 minus alpha x into mg dx, right? Now we can integrate this mg into, and the limit, the particle is, the box is going from this object, particle of mass m moves from x is equal to 0 to x is equal to L, right? So integral 0 to L. So mg I taken out. By integrating this, you can write a mu 0 x minus alpha x square by 2 integral 0 to L, right? Now by substituting this, mg into mu 0 L minus alpha. What is alpha value? Alpha value we solved here, mu 0 by L, then mu 0 by L into L square by 2. That is, we can write here, that is equal to, so this L square cancel, mu 0 L minus mu 0 L by 2. Then mg into half into mu 0 L. Then see here n mu 0 mgl. Then what is n? N is equal to 1 by 2. Then option 4 is correct, right? Now let us go to question number 2. The mean free path of a molecule in an ideal gas A is half of the another ideal gas B. That means lambda B, they given us half of lambda A, where lambda A and lambda B is the mean free path of A and B respectively. And here it is given that the diameter of a spherical molecule of gas A, and it is twice that of the diameter of the molecule B, then dA is equal to twice of diameter B, right? That means the radius also. All right. Now what we need to find, the relation connecting number densities. What is a mean free path we studied? Lambda is equal to 1 by root 2 pi n t square, right? Then Na is equal to, we can write as 1 by lambda A dA square, and NB I can write as 1 by, it is proportional to, right, lambda B dB square. So I can write Na by Nb is equal to, right, that is equal to lambda B by lambda A into, so dB by dA the whole square, that I can write as RB by RA the whole square. Why? Because 2 times radius only. Right. What is lambda B by lambda A? That is equal to 1 by 2 into, right. So, and this is 2 square, right. Then RB by RA. RB by RA is equal to 1 by 2. Sorry. So, this is 2 and this is 1 by 2 the whole square. Right. Then it is 1 by 2. Then Na by Nb is equal to 1 by 2. Then Na is equal to 1 by 2 Nb. Right. So, here given is, this is 2, lambda b is 2 times of lambda a. Alright. So, option 4 is correct. Then question number 3 is, two identical inductors are connected in two different configurations. One is P, one is Q, where time varying current I of t flowing as shown in the figure. The induced EMF between the points A and B for configuration P is EP and configuration Q is EQ. What we need? The ratio EP by EQ. See, here current I of t that only passing through, right, complete circuit. But here, see, this I divided into two parts. Here I by 2, here I by 2. So I can write EP, right. EP is equal to, between A and B, if I consider what is EP? L into, for inductance EMF is di by dt. But EQ is equal to L into current is, so this A and B or this A and B, that is parallel only, same voltage. So L into, but current is off only, right. So now EP by EQ you find means 2 come up, then EP by EQ is equal to 2. Then option 4 is correct, right? All right. So next is question number 4. For a sound wave, if number of nodes, right, fifth harmonic of an open pipe is n, and that for ninth harmonic of the same pipe which is closed, then the ratio n by m. So in closed pipe we have m nodes, and open pipe we have n nodes, right. See, in an open pipe, see what is, suppose one open pipe, then how fifth harmonic you draw? Like this only, 1, 2, 3, 4, right. This only 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This is the fifth harmonic. Then how many nodes are there? That is only they given n. N is equal to 5. Now, what is the ninth harmonic in a closed pipe? That is, we can draw like this. See, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. See, this is the ninth harmonic. So, 1 is to 3 is to 5 is to 7 is to 9. So, ninth harmonic is this, right? 1, 2, 3, 4, 5 nodes are there. Then here also m is equal to 5. They are asking n by m, then n by m is equal to 5 by 5, that is equal to 1. Then which is correct? Option 3 is correct, right? Right. Now, question number 5 is, consider a long solenoid of length L and radius R. If n is the number of turns per unit length mu0 and permeability of space given, the inductance of the solenoid is. What is the inductance we studied? See, one solenoid you consider means, right, we studied phi is equal to Li, but phi is equal to BA Li, but B is equal to mu 0 N I, right, into A, that is equal to Li. Current cancel. Right now, small n is equal to what? Capital N by L only. Then total current. See, if you write total current, we have to write this I as Ni, because each turn enclosed with the current I. So before cancelling, another N come here, right? That Ni only the net current in the solenoid, enclosed current. Then I cancel, then mu 0 N square. What is A, right? So N is equal to A is equal to pi R square, right? Now, what is the option? Mu 0 N square R square L, that only inductance. Then option 1 is correct, right? Now, question number 6. Consider a particle moving along a straight line whose position as a function of time is given, right? So, here S of t given alpha t square minus beta t plus gamma, where alpha is equal to 1 meter per second square, beta is 6 meter per second, gamma 5 meter. The average speed of the particle from t is equal to 0 to t is equal to 6. Right. See, average speed, we first of all we can write this S, right? S is equal to alpha, beta, gamma value we can substitute, then t square minus 6t plus 5. Then what is velocity? Instantaneous velocity is, that is 2t minus 6. Now, suppose this question we can do in different way. Find t is equal to 0, what is the t is equal to 1, t is equal to 2, t is equal to 3, t is equal to 4, t is equal to 5. We have consumed lot of time. So graphical method is very easy. Why? Because see, this velocity time graph, if I draw, see, t is equal to 0 means what is y value? This velocity value is minus 6, right? This is velocity, this is time. Now t value is 3 means what is the value? This turns to 0, right? And also this is mx plus c format, so that we can write a straight line. Now at t is equal to 6, at t is equal to 6, then what I can write it? 2 into 6, that is 12 minus 6, another 6. But t is equal to 6, you get a plus 6 value, right? This is the graph, right? Now, you know, area of velocity time graph, what? That is the distance without considering the magnitude. Then 2 times half into base into height. This is the distance, right? What is that? This is 2 to cancel, 18. So 18 meter is the total distance covered from t is equal to 0 to t is equal to 6. Then speed, what? Average speed is equal to distance by total time, that is 18 by 6 is equal to 3. Then option 3 is correct, right? Now next is 7th question. Consider the following nuclear reaction: uranium converted into thorium and helium. Uranium, thorium, helium mass separately given. Q value. What is the Q value formula? Mass defect into, right, c square, or 1 AMU total energy, right? So how we can write it here? What is mass defective? Mass defective, this left hand side mass, that is they given 238.05 minus what is the total product mass, that is 234.043, right, plus 4.003, right? This much u, that means this much into u, right? This is the mass defect. Now what is the energy, binding energy, or Q amount released? This difference into, right, 1 AMU corresponding energy, what is that? What is 931.5 MeV? By solving this, you get a 3.736, right, 726 into MeV. 1 MeV is equal to into 10 raised to 3 kilo electron volt. So you can write it 3726 keV. Right, then option 1 is correct. Right. Question number 8 is, a beam of light falls on a metal surface such that photoelectrons are generated. If power of the light source start decrease linearly with the time, then variation of the photocurrent I and a magnitude of the stopping potential with respect to time represent. See, light is falling and photoelectrons are emitting, then there is a photocurrent, there is a stopping potential, right? That variation with the time only asking C, but it is given that power of the light source decrease linearly with the time. What is power? Power is equal to n h nu by t, because n photons are coming, total energy n h nu with respect to time. Now, suppose 2 photon come, 10 photon come, 15 photon comes, photon energy not changing, frequency not changing, photon frequency not changing, but this n only decrease, power decreasing with the time means what is decreasing? Frequency of light not changing, it is fixed, right? So only n only decrease. N decrease means what we studied, intensity of light decrease, that means photocurrent decrease, then photocurrent decrease, right? But if sufficient frequency is there means for a particular photon, h nu is equal to h nu 0 plus ev. As long as frequency not changing, the stopping potential does not affect it, so it is not going to change, right? Then option 1 is correct, right? All right. See, question number 9. Three identical capacities PQS, each having capacitance C given, right, are connected battery voltage V as shown in the figure. If the energy stored in the capacitor P and total energy stored in the system UP and UT, then UP by UT. See, here suppose potential, this is C, here charge getting is CV, definitely here charging getting is CV by 2, right? Why? Because here half the capacitance only, right? C by 2 only, here C. Now, what is the energy in UP? That is Q square by 2C. That means UP is equal to Q what is CV by 2 the whole square by 2C. Then UP is equal to 1 by 8 CV square. Right. Now, total if I calculate say UT, this capacitance energy that we can write CV by 2 the whole square divided by 2C. Again, same capacitance, same charge only flowing, then CV by 2 the whole square divided by 2C plus, and this capacitor has some energy that is half CV square, right, half CV square divided by 2C, right. Now, by adding this and all, you get a UT is equal to C 4 3 by 4, then 3 by 4 CV square. Now we divide this UP by UT is equal to, right, that is 1 by 8 CV square divided by 3 by 4 CV square, right? So this is 4 go up, then 6 1 by 6 CV square, right? CV square cancel, then 1 by 6 only, right? Then which is the option? Option 4 is correct, right? Good. Question number 10 is, water flows in a streamlined motion through a horizontal pipe of circular cross section as shown in the figure, right? And the pressure difference water between P and Q. See, here one P, here one Q. Then P minus PQ, they given. What is that? 15 Newton per meter square, right? The area of cross section at P and Q respectively, here 40 centimeter square given, here 20 centimeter square given, right? Now, the rate of flow through the pipe, rate of flow we need. As per the equation of continuity, rate of flow is equal to A1 V1 is equal to A2 V2, right? What is A1? 40 into, right, V1, that we need V1 and equal to 20 V2. Now V2 you can write as 2 V1. Now equation of Bernoulli's principle, it is a horizontal pipe. We can write a PA plus half rho V1 square. It is at the same level, then potential energy term we not consider. So I am not writing Pb plus half rho V2 square. Right. Then Pa minus Pb equal to half rho into V2 square minus, see this V2 square minus V1 square, but V2 is 2V1. So I can write as 2V1 square, that is 4V1 square minus V1 square, right? Now we can solve Pa minus Pb, that is given, what is the value Pa minus Pb given? 15 into this 2 come here, and this rho value for water only used streamline water flows. So it's 1000 only, its density equal to 3 into V1 square. Then V1 you can solve, right? After getting V1, what is the rate of flow? A1 V1, A1 V1, right? When you solve this, you get a 0.1 meter per second. Now multiply area. Area is what? Area. See, this area we consider, right? Then 40 centimeter square, that is 10 raised to minus 4 into, right? That is 0.1. So answer is 400 in terms centimeter cube per second. That is 400 centimeter cube per second, right? Now, question number 11 is, a current I0 flows through a metallic circular loop of radius R as shown in the figure. The resistance of the segment ABC is half of that of the ADC. The magnitude of magnetic field at the center of O of the loop is. Now see here, ABC resistance is, they given half of ADC. That means this side resistance R by 2, this side R. Then double part of the current flows through this. That means here 2 by 3 I0. Here what? 1 by 3 I0. Now what is the magnetic field? One is upward and due to this it is downward. So magnetic field at the center due to this is in opposite direction due to this, right? So we can write net magnetic field is V1 minus V2. But you know, magnetic field due to a semicircle is mu 0 I divided by 4R minus second semicircle is I2 divided by 4R, right? Now we can substitute that mu 0 by 4R we can take out. Here 2 by 3, this I1 is 2 by 3 I0, and here is 1 by 3 I0. Then mu 0 I divided by 12R is the answer, right? So option 1 is correct, right? Now question number 12 is, in the measurement of viscosity of a liquid terminal velocity experiment, right? Spherical ball of same radius having different densities are used. The variation of terminal velocity with the ratio of spherical ball density and density of the liquid is given by. What is the terminal velocity equation we studied? That is V of t is equal to 2 by 9 R square G divided by eta into rho minus sigma, right? So sigma minus rho, all right. Now we can take V of t is equal to, take this rho. Why? Because we need graph between rho, sigma by rho, right? So rho we take out, 2 by 9 eta R square G rho into sigma by rho minus 1, right? Now suppose in this graph, what we can say, sigma by rho value is 1 means 1 minus 1 is equal to 0. Then whole graph must be start from 1, right? Also, this equation is in the format y is equal to mx plus c. That will, it should be a straight line. So starting from 1 with a slope, there is a straight line, means option 1 is correct, right? It will finish. Here, two planets P1 and P2 with equal mass have a radii R1 and R2 respectively. R2 given R1 by 2. SK speed of P1 and P2 are V1 and V2 respectively. Then V2 by V1. What is the escape speed we studied? Escape speed is root 2 gm by R1. Right, gm by r. Then v2 by v1 you can write as root r2 by r1. Am I right? But r2 they given r1 by 2. Sorry, this is r1 by r2, v2 by v1. R2 is r1 by 2, then r1 divided by r1 by 2. Then answer root 2 is correct, right? All right. Question number 14. In a solar system, time period of revolution of a planet tracing a circular orbit of radius r is proportional to. Time period, already we studied equation. What we studied, a time period is equal to 2 pi root r cube by gm. Right. Then time period only proportional to, this is proportional to r raised to 3 by 2 only, right? Option 2 is correct, right? All right. So this is direct question. Now another question is question number 15. Two infinitely long parallel conducting wire A and B carries current I and 2I respectively. In the same direction, the wire A has uniform mass per unit length lambda and lies insulated on the floor, and B is fixed at a height h. The minimum magnitude of h so that wire A does not rise. The situation is, on the floor you have a wire, right? And that is A. Another wire B. Their separation is h. Now, because this carrying a current I and this carrying a current 2I, it should not rise because of this attraction, means it should balance with its weight, right? What is the force per length we studied? Force per length is equal to, right, that is a linear charge density. Its mass density is given, then mg by L, that is lambda L g divided by L, right? LL cancel, lambda g. This force per length, gravitational force per length, that should match with this force that is attracted towards this wire. What is that? Mu 0. What is parallel conductor's force? Mu 0 I1 I2 divided by 2 pi r. That is mu 0. What is I1? I and 2I divided by 2 pi r. R is h, right? Now this I can write as h is equal to mu 0 I square divided by, right? This is mu 0 I square, this 2 cancel, right? Divided by h is equal to pi lambda g, right? So we have a pi lambda g. Then which is the option? Option 2 is correct, right? All right. An ideal Zener diode with breakdown voltage of minus 3 volt is reverse biased with a negative input voltage minus 5 volt. So here we a minus 5 volt. Then at breakdown voltage across the diode is constant, that they given breakdown voltage, that is minus 3. What is remaining across this? Minus 2. Then magnitude of that voltage is across A and B, that is 2 only, right? Then option 2 is correct, right? Question number 17. In an adiabatic expansion, the temperature of 1 mole of an ideal monatomic gas, gamma is equal to 5 by 3, decreases from 60K to 50K. The work done by the gas in the process is, see, work done by the gas in the process is, that is, in adiabatic process, R by 1 minus gamma into T2 minus T1, if n moles are mu, but they given ideal monotone decreases, the work done universal gas constant, okay, 1 mole, then 1 into 8.3 into 1 minus, what is gamma given? 5 by 3 into T2 minus T1, right, that is 50 minus 60, that is minus 10. By doing this, here also 3 minus 5 minus 2 by 3, right, then you get an answer as 124.5 joule. Then option 3 is correct, right? All right. Question number 18. A ray of light with wavelength lambda is incident on a 3 different photoelectric cells. This is 1, this is 2, this is 3. And a photoelectric cell with its threshold wavelength, this is lambda 1, this is lambda 2, this is lambda 3. And the magnitude of stopping potential also given V1, V2, V3, right. The relation between lambda, threshold wavelengths, see some lambda falling on all the material, okay. Then the relation between lambda 1 less than lambda, this lambda 1 less than lambda means here no photoelectric emission, because Hc by lambda is equal to Hc by lambda 0 plus EV1 for a first case, right, first case. Then this lambda 1 threshold frequency for this is less, means this part is more, that means applied energy not sufficient to case photo, then V1 is 0, V1 0 given 2 option is there, right. So next we have to check V2 nature what, here lambda 2, how connected lambda 3 is more, lambda 3 is more means see lambda 3 is more than lambda, then there only we have a stopping potential more, right. Then which is correct? Option 1 is correct, right. All right. Question number 19. A photon and an electron, each of 20 electron volt energy, move in free space. The ratio of linear momentum of electron to photon. See, momentum of proton, right, electron to photon. What is any particle momentum is root 2m e, because energy is same they given, right, both are 20 electron volt divided by, but photon momentum is e by c only. Then by substituting that root 2m by e into c, that is root 2 into m value given, right. Mass of electron they given, that is 9 point into 10 raised to 9 into 10 raised to minus 31, and this e value they given, that is 20 electron volt, 20 into 1.6 into 10 raised to minus 19, and a C value, that is 3 into 10 raised to 8. By substituting this value, we get a option 3 as the answer, right? Which one of the following measurement require index correction? See, index correction is a method using a optical bench experiment. It is a method to find focal length. It is a theoretical question, direct question. Measurement of focal length lenses using optical bench, right? All right. Question number 21 is, a unit positive point charge is taken slowly through an infinitesimally thin tube that inside a charge, unit positive charge only, and the sphere having a charge density rho, right. As shown in the figure A, an initial and final position A and B, which is at a distance 2r and 3r from the center. The work done to moving from here to here, that they given rho r square by n epsilon 0. We need to find this n value. What is the work done? Work done is equal to moving charge into potential difference, right. Moving charge they given 1. Now due to this sphere, what is the potential at this point? At this point, that is k q divided by 3r minus k q divided by 2r, right? That is w is equal to, so we can write a k q divided by 6r, but k is magnitude take, then k is what, 1 by 4 pi epsilon 0, and q what, 4 by 3 pi r cube rho, because charge density is equal to charge per volume, then charge into density into volume, that is the, because it is a sphere, we can give volume as 4 by 3 pi r cube into divided by 6r. Now this 4 cancel, 3 into 6 18, then you can write as rho r square divided by 18 epsilon 0, then here this n value, that is should be 18, right? All right. Now next question is, consider three media PQR with refractive indices 1, 1.25 and 1.5 respectively. The medium Q having thickness 5 cm is placed between extended media P and R as shown in the figure. An object O is placed at the center of medium Q. If viewed from point P near the normal direction, the apparent depth, suppose here looking from this end, apparent depth given, right? Looking from this side also, apparent depth given. What is apparent depth? Apparent depth is equal to n1 by n2 into real depth, right? That is d real. So d real what? That is 2.5, right? So dA is equal to, in first case refractive index is 1, and here refractive index 1.25 into real depth 2.5, that is 2. Now second case, what is a real depth? This is dA1, say this is dA2, or this is h1 given or h2 given in the question, right? So here the medium is looking from this medium only, then 1.5 divided by 1.25 into 2.5, then this is 2 into 1.5 3, then h1 minus h2, that is equal to 2 minus 1, right? That is equal to 1, then option 2 is correct, right? All right. So okay, so 3 minus 2, sorry, 3 minus 2, that is equal to 1, so that one, not 2 minus 1, right? Next question is, see, a frictionless circular wire of unit radius is fixed horizontal plane, see, and the point particle unit mass start moving simultaneously from the point theta is equal to pi by 2, right? And identical uniform angular speed in opposite direction, and meet again at the point theta is equal to pi by 2. During this time, which of the following diagrams schematically represent total momentum of the two particles, right? See, one particle. So let me draw a diagram first. See. So here one particle. So here another particle here. Both are starting from here theta is equal to say pi by 2. So this going in this direction, say like this. This going in this direction, say like this. Now what is the momentum of this? Suppose this angle is theta. This is momentum is mv, means mv sin theta. This is mv cos theta. And similarly here it has two components. This is the momentum mv direction. So this angle is theta, means this is mv sin theta. This is mv cos theta. Now this and this see opposite direction cancel out. Then we have two cosine components, that is delta p, total momentum p1 plus p2 is equal to 2 mv cos theta. I taken magnitude only, it is downward negative, right? Now if theta pi by 2 means what is the total angular momentum? Theta pi by 2 means it will be 0. So here momentum pi by 2 means it will be 0, right? And theta is 0 means it will be maximum. So here look here, here 0, here 0. Theta pi by 2 time it will be 0 and theta minus pi by 2 time it will be 0. O0 is 1, that time it will be maximum. Option 3 is correct, right? The temperature of a metallic sphere of radius r is increased by a small amount delta T, right? If the linear coefficient of thermal expansion of the metal is alpha, right? The approximate increase in the volume. How volume expansion of a cubical body is we related, that is V is equal to gamma V delta T, right? But we know gamma is 3 alpha, right? So we need to find the approximate increasing, this is delta V only, right? So delta V only we need. Delta V is equal to gamma into what is volume? 4 by 3 pi r cube delta T. And also we know delta V is equal to what is gamma? Gamma is 3 alpha. How gamma is related to alpha? That is gamma is equal to 3 alpha. That is 4 by 3 pi r cube delta T. 3 cancel. Then 4 pi r cube delta T, which is the option alpha delta T. That is option 3 is correct, right? A cylindrical cork of uniform density floats in a liquid of density ρ1. If the cork is depressed slightly and released, it oscillates harmonically with the time period t. If the same cork floats in another liquid of density ρ2, then the similar oscillation has time period 2t, the value of ρ2 by ρ1. See, we studied in theoretical section one ball or one block, you press it in a liquid of density, it goes some depth and it come back, then oscillate like this, right? So what we studied there, time period of oscillation equal to 2 pi root m by rho ag, right? This equation we studied. Then t is equal to proportional to 1 by root rho density. Then t1 by t2 is equal to what we studied, root rho 2 by rho 1, right? Now they given one information rho 2, then similar oscillation time period 2t, then 1 by t2 you can give 2t1. So here you substitute 2t1 means t1 t1 cancel, then rho 2 by rho 1 is equal to square both side 1 by 2 square, that is 1 by 4, then option 4 is correct, right? One main scale division of a vernier scale, MSD given, that is 1 millimeter, and number of vernier scale division, that is 10, right? When both jaws touch each other, the vernier scale shift to left of 0 of the main scale. And such a way, fourth vernier scale division coincide with the division of the main scale. That means if this vernier caliper measures the length of a 1 centimeter, what is the actual length? See, what is the zero error in this case? Zero error, what we studied, negative of, right, number of vernier scale division, that is 10 they given, 10 minus, and what is the coinciding number, that is fourth vernier division, then 4 into, right, what is the least count of 0.01 centimeter? 0.01 centimeter. That is 0 minus 0.06 centimeter. Right. Now you are measuring 1 centimeter actual length, a wire of length 1 centimeter. Then 1 centimeter minus zero error. What is zero error? Minus 0.06. Then 1.06 centimeter only, but no answer given here. So this is going to be a bonus mark, right? A solid sphere A of radius capital R and mass m. So that means this body has mass m, this body has small mass, and this radius is small r, this radius is capital R. Then about the large sphere center, what is the moment of inertia? Say I can write I is equal to 2 by 5 solid sphere only, mr square, plus its own moment of inertia 2 by 5 small m r square, and the distance, this is r and this is capital R. By parallaxis theorem, this distance square, mass into this distance square, that is m into r plus r the whole square. Similarly, here about the small sphere axis, IB is equal to 2 by 5 mr square plus 2 by 5 small capital small mr square plus, but with this you have to add this parallel distance square, right? So we can write 2 by 5 mr square plus and 2 by 5 capital mr square plus this distance square, that is again m into r plus r the whole square. But this is capital M, right? This is capital M. Now by subtracting this cancel, this cancel, we need IA minus IB, then r plus r the whole square you can take out here small m minus capital M. So which is the option? Option 2 is correct, right? All right. Consider a spring of mass, simple harmonic oscillator in one dimension. The mass of the particle is m kg and the spring constant is k Newton per meter at a given instant. The extension of the spring x meters and the speed of the particle is v meter per second. On the xv plane, if the graph v as a function of x, that is given as a circle, then the correct option is, see, what is the energy, from the energy conservation, what we know in a simple harmonic motion, total kinetic energy plus total potential energy, this is a constant, right? So this I can write as, see, v square by, we can write this as 2e by, so or we can write this as v square divided by 1 is equal to v square divided by, see, this m go down and this e, then 2e by m, right? Plus here x square divided by, we can write this as 2e by a. Now if it is a circle means Vx graph is a circle means this part should be equal to x square plus y square is equal to r square only. So this should be come here, that means this should be equal to this, that is 2e by m must be equal to 2e by k, this cancel, then m is equal to k, then option 2 is correct, right? The lens combination, question number 29. The lens combination as shown given figure. Focal length of the first lens, that is given plus 10 and this is concave, that is minus 10. Position of the image. See, first you find u is equal to 10, sorry, u is equal to 30 because first lens object is at 30 distance and focal length say given 10. Find the image distance using 1 by v minus 1 by u is equal to 1 by f. Then you get first v1 as 15 centimeter, right? So 15 centimeter getting means from this lens somewhat here the image form, that is 15 centimeter. But this distance is 3 centimeter. What is this distance from the concave lens? 12 centimeter. This image act as an object for this concave lens. Then what is nu u? So next step u is this 12 only. This act as an object, but it is plus 12 only. Why? Because ray going in this direction, we are measuring object distance to the same direction only. So that is positive, right? But this focal length of this lens is next minus 10. Now again you apply 1 by v minus 1 by u is equal to 1 by f. You get a new image distance will be minus 60. That means from this lens about 60 centimeter only this image forms, right? Then 60 centimeter from the left of the concave lens. Option 2 is correct. 220 sine 2 into 10 raised to 3t volt applied to a series LCR circuit. Then the current amplitude in the circuit is, see, suppose here this inductor value, capacitor value, resistance value. What is XLA? XL is equal to L omega, right? L given, what is L? 10 into 10 raised to minus 3 into 2 into 10 raised to 3, that is 20 ohm. What is capacitive reactance? That is 1 by C omega, right? Capacitance value is given, that is 25 into 10 raised to minus 6, and omega again 2 into 10 raised to 3. This also 25 into 52, then 20, again 20 ohm. Then capacitive reactance is equal to inductive reactance, means the circuit is in resonance. That means current amplitude I0 is equal to V0 by R only, because Z is equal to impedance is equal to R. Here what is V0 value? 220 divided by R. R is they given in the circuit, R is 100 ohm only. Then this is 2.2. That means option 1 is correct, right? All right. Questions. Question number 31. A thin horizontal disc of rotating about the vertical axis passing through the fixed center of its angular momentum is LA and LB, computed about the point A and B respectively. OB given 2 into OA. This distance is double of this distance. LA by LB, angular momentum about this point, LA by LB, right? That is equal to, see what is LA? I omega only, right? Angular momentum I omega, but this it is rotating its own axis, right? So this distance not a matter, divided by I omega. So in all the cases I is same, this disk moment of inertia only, and omega is fixed only, it not varying. So this ratio will be always 1. Then option 3 is correct, right? See, a conducting loop of finite resistance lies in the xy plane. There is a constant magnetic field in the z direction. The area of the loop they given. What is the area given? Area is equal to A0 into 1 plus sin t, right? Now, the figure correctly indicates the behavior of power. Power is equal to what? E square by R. Now what is E? E is equal to minus d phi by dt, that is minus b into dA by dt. On differentiation, this is sin omega t on differentiation, cos omega t. Then power is equal to b square A0 square cos square omega t divided by R. So it is proportional to cos square omega t, right? Cos square graph is like this only, right? This is sin square omega t graph. So option 2 is correct, right? Next question is, see, look, a point charge cube placed inside a cavity. See, here there is a cavity, there one charge q is placed, right? Consider the point A, B, C shown in the figure, where the magnitude of the electric field are EA, EB, EC respectively. The point B and C are at this B and C from this distance and this distance same. So here electric field from the charge this distance same, this distance same, means electric field B at electric field C is equal, right? We can say. But EA is equal to value what? EA not equal to 0. Why? Because within the cavity at a distance, here one point A measured. So here one charge is there. Then at this point electric field not equal to 0. But EB is equal to EC. Then option 2 is correct. Right? Alright. Question number 34. Consider a fixed uniformly charged insulating sphere, right? And a total charge it has q, right? Radius r. Now what is given? A point charge minus q, very less than q, and mass m released from the rest at a distance 3r. From 3r distance, another charge minus q releasing. Now they asking, when the point when the charge reaches here at the surface, what is the velocity? So reaching time it has a velocity. That what velocity it is? It is this moving charge potential difference. Suppose this point, what is the potential difference? That work done is the charge into potential difference, that only converted into kinetic energy, right? What is VB? K minus QQ, right? That is KQQ, KQQ divided by initial separation 3R, KQQ divided by final separation, what? That is R only, if it reaches on the surface. Now, half mv square is equal to, so, right, so potential difference, so we need not this small charge, already charge value we given, so minus q we taken out, right, the given moving charge. Now kq by r into 1 by 3 minus, right, 1 by 3 minus 1, that is minus 2 by 3, right? Then this cancel, then what is the answer? You can put here 1 by 4 pi epsilon 0, then half mv square is equal to 1 by 4 pi epsilon 0, k is 1 by 4 pi epsilon 0, then here 2q divided by 3r, right? Now this 2 cancel, then here 1 3 is pending, then QQ divided by, right, here outside 1q is there, right, that minus and minus cancel, then QQ we can put a QQ divided by 3 pi epsilon 0 mr, then which is the option? Option 3 is correct, right? All right. Question number 35. In Geiger-Marsden experiment, the number of scattered alpha particle n of theta is plotted as a function of scattering angle theta. Which of the following represent the correct plot? See how we studied the scattering angle. Scattering number of particles scattered is proportional to 1 by sine raised to 4 theta. Then sine value increases. This is the shape of graph we studied, right? So option 1 and 2 wrong. Now let us go to, so option 3 only that is showing, right? Then option 3 is correct, right? Question number 36. Consider two circuits A and B, each having two resistors. One of them positive temperature coefficient of resistance, other having negative temperature coefficient of resistance, as shown in the figure. So let us see next page. See, this is the figures. Now, as the temperature increased, what describes the variation of current? See, here first connection is series, right? Series means what is the net resistance? R1 plus R2, that is R0 into 1 minus alpha delta t plus R0 into 1 plus alpha delta t. That is R is equal to, what we get? That means 2R0. This plus and minus cancel, right? Then current is equal to V by 2R0, right? So here no temperature depending parameter. So IA not depend on temperature. I remains constant only at this condition. But I remains constant given in which option? Both IA and IB remains. So here, so B natural also we need to check. But here parallel connection only. In parallel connection, effective resistance is R1 R2 divided by R1 plus R2, that is R0 into 1 minus alpha delta t plus into R0 into 1 plus alpha delta t divided by R1 plus R2, that is R0 into 1 plus alpha delta t plus R0 into 1 minus alpha delta t. Here the answer is 2R0, right? Here R0 square into, this is A plus B into A minus B, then 1 minus alpha square delta t square. Now look here, this parameter depends on alpha. So when alpha temperature increases, this must increase, IB increase, because 1 minus only given. Then IA remains constant and IB increase. Option 1 is correct, right? Question number 37. consider that sigma kb we represent a Stephen constant, a Boltzmann constant, and Wien's constant. Then the dimension of sigma k inverse b, right? So sigma b divided by k. Now what is sigma? Sigma is intensity per temperature, right? Then that is mt raised to minus 3 divided by k raised to 4. That is in the formula we studied it. That is energy is equal to E sigma A divided by T raised to 4, energy per time, using that formula. B is equal to what? B is equal to, we studied lambda T. That means Lk, right? Divided by this Boltzmann constant, right? That is energy per temperature. That is ml square T raised to minus 2 divided by K, right? So by substituting this whole, you guessed option 1 as the answer. All right. All right. Now let us go to another question. See, an electromagnetic wave traveling in a lossless dielectric medium having dielectric constant epsilon r 9 has the electric field Ex, that is E0 sin kz minus 2 pi into 10 raised to 6 t. Okay. Now E0 is the amplitude and k is the wave vector. Among the following option, incorrect choice is, right? See, we know magnetic field is E0 by V only. See, B we write B0. See, B0, By, B is in terms of B0 into velocity only, right? Because what we studied E is equal to Cp, right? So B is equal to E by C only come, right? So here E0 by B only come in magnetic field. So this definitely. Now regarding, so two option making here incorrect. So this is a multiple option correct question, but we can write only one question. So you get a bonus mark here, right? Two option found to be incorrect. You can calculate the wavelength of the electromagnetic wave inside the medium is 300 meter. That is not 300 meter. How you can calculate it? See, you calculate 1 by root mu 0 epsilon 0, right? Right, mu 0, and then velocity find. Once velocity find means v is equal to, you can apply f lambda, right? And this omega value is given like that. You solve means it is found that it is not 300 meter. That's why it is a bonus mark, right? Next question is, 1 mole of ideal monatomic gas undergoes cyclic process as shown in the figure. The total heat is supplied, right? See, heat is supplied means it is PV diagram. What is the heat supplied is area under this. That is the energy or heat supplied, right? So that is what is this area is 2, 5 minus 2 into 300 minus 200. That is 200. That is 600 joule, right? Then option 3 is correct, right? All right. Question number 40. Consider that an electron revolving in an excited state of hydrogen atom with velocity given, the radius of the orbit is x into 10 raised to minus 9 meter given. The value of x is, and 1 by 4 pi epsilon 0 electron charge, electron mass. In hydrogen atom, how we find the radius? mv square by r is equal to 1 by 4 pi epsilon 0 e square by r square. Then radius you can find 1 by 4 pi epsilon 0 value 9 into 10 raised to 9, e square value 1.6 into 10 raised to minus 19, and divided by, right, this m, right? M is what? M is equal to, they given 9.1 into 10 raised to minus 31 into v square, square of this, that is 25.6 into 10 raised to 10, By solving this, you get a 1 into 10 raised to minus 9. That means x into 10 raised to minus 9. Then x is equal to 1. Option 4 is correct. Right? Question number 41. A car travels on a circular racetrack of radius 50 meter, which is banked at an angle theta. Right? If the car travels at a speed 10 meter per second, then wear and tear on the tire is minimum. That means taking the acceleration due to gravity be 10 meter per second square, the value of theta. What formula we studied? If friction is not there means, that means v square is equal to rg tan theta. Then tan theta is equal to v square by rg. Then velocity 10 square, r is 10, r is they given 50 meter, and this is again 10, then this cancel. Theta is equal to tan inverse 1 by 5. Then which is the option? Option 1 is correct. Right? All right. The question number 42. Three identical PN junction diode D1, D2 and D3 are connected across the battery as shown in the figure. Right. The width of the depletion region D1, D2, D3, W1, W2, W3, where the depletion region width is maximum, reverse biased diode. Then W3 will be first maximum. Right. And then non-connected diode also. This is open circuit. Then next is that W3 greater than then W2. This is forward biased. Then depletion region very less. Then W1. Then W3 greater than W2 greater than W1. Option 3 is correct. Right? The following table represent the part of the electromagnetic spectrum and their corresponding major applications. Right? Then microwave, you know, it is cooking. Microwave oven we are using for cooking only. Then P is connected for warming the food. UV rays we are using for a cancer. UV rays we are using for purifying water only. Right? For purifying water only, UV rays. But gamma rays we are using for treating cancer. Right? Cancer cell destruction we use gamma rays. Next, radio waves, you know, mobile communication and all, for AM FM communication system only. Right? Then which is the correct option? Option 3 is correct. Right? P2 2 and Q2 1 and R2 4 and S2 3. Right? Then option 3 is correct. Right? A bulb B of mass M at rest is hanging vertically from the ceiling by a massless string of length 10 meter, as shown in the figure. Right? But yes, figure is given here. Now, point mass A of mass traveling horizontally with the speed. One mass is moving with a velocity. The bulb B writes after hitting this will write a height h. Right? Now, taking the acceleration due to gravity, neglecting the size of the bulb and the value of h. This is a direct question. See, after reaching a height, what energy it has? mgh. What energy converting? Here half mv square. By energy conservation, half mv square is equal to what? mgh. Mass cancel. We need to find the height value. Right? Then v square by 2g. That is 100 divided by 20. That is 5. Right? And option 3 is correct. Right? An ideal gas made of polyatomic gas, each of molecule has 3 translational, 3 rotational and f number of vibrational. See, 1 vibration means 2 degrees of freedom. F number of vibration means 2 vibration. This is the total number of degrees of freedom. Right? Now what they are telling, if the ratio of heat, gamma value they given, gamma is equal to 8 by 7. Value of this F value we need. How gamma and F connected? Gamma is equal to 1 plus 2 by F. Right? F dash. Now gamma is equal to 1 plus 2 by 3 plus, so 3 plus 3 6, then 6 plus 2f, right? F we need to solve. Gamma value they given, that is 8 by 7, right? So I am replacing this with 8 by 7. Then 8 by 7 minus 1 is equal to 2 by 6 plus 2f. Then 1 by 7 is equal to 2 by 6 plus 2f. Then 6 plus 2f is equal to 7, 14, and 2f is equal to 14 minus 6, that is 8. Then f is equal to 4. That means 4 coming, option 1 is correct, right? All right. Okay, this is all about NEET 2026 June 21st exam discussions. So it is found question paper a little bit lengthy and tough, but definitely cutoff mark will reduce, and time consumption also we unable to do within the 1 hour time limit. That is the major issue, right? So definitely to do all the problem, minimum 1 hour 45 minutes is required. That is the main challenge here. Don't worry, cutoff will be reduced. Thank you for all.